Hi guys, today I will be solving question 13.36 from Young and Freedman's University Physics textbook. A visit to Santa. You decide to visit Santa at the North Pole to put in a good word about your splendid behavior throughout the year. While there, you notice that the elf Sneezy, when hanging from a rope, produces a tension of 395 newtons in the rope. If Sneezy hangs from a similar rope while delivering presents at the Earth's equator, what will the tension be? Recall that the Earth is rotating about an axis through its north and south poles. Okay, so the first step to this question is drawing a free body diagram for Sneezy when he's on the North Pole and then when he's on the equator. Okay, so when Sneezy is at the North Pole, he is directly on the Earth's axis of rotation, which means that he is experiencing no circular motion because he is right on that axis. Okay, there's no radius from the axis. In order for something to experience circular motion, there needs to be some type of radius from the axis of rotation. So in that case, the free body diagram is simply going to be gravity pointing down and tension pointing up. Okay, now assuming he's hanging from rest, the two forces acting here is going to be tension positive because it's pointing up, and gravity negative because it's pointing down. And we're just going to say that tension equals Fg, which means tension equals the elf's mass times acceleration due to gravity. Now, when Sneezy is on the equator, he is a certain radius, the radius of the Earth, away from the Earth's axis of rotation, which means that he is going to experience circular motion, which means that we need to include the centrifugal force in our free body diagram. Okay, so of course Sneezy is going to experience gravity pointing towards Earth's center of mass, and he is hanging by his rope still. Okay, so tension. Now the third force we include here that's different from the North Pole is the centrifugal force, which is opposing the force of gravity pulling inwards. So for this situation at the equator, the forces still equal 0. So that's 0 equals tension pointing up. So positive plus the centrifugal force pointing up. So positive minus gravity pointing down. Okay, and if we isolate for tension, because that's what we're solving for, it will be tension equals the force of gravity minus the centrifugal force. And what that will be is mg minus mv squared over the radius of the Earth. Okay, and all of that is equal to tension. Now, in this equation, okay, we're solving for tension, yet we still don't know the mass of the elf, and we also don't know the speed, okay, the tangential speed of the elf on the equator. Okay, so let's start off by solving for the elf's mass. Okay, so we know that at the North Pole, okay, the question tells us that the tension at the North Pole is 395 newtons. So here we can plug that in. So 395 newtons equals m times 9.81 meters per second squared. And now if I do the division, I get 40.3 kilograms. Okay, so that is our mass of the elf. Now for the speed. Okay, so this is the tangential speed. Okay, so it would be like this way as a vector. We can use our simple formula for speed, which is, ooh, I don't know what happened there. Velocity equals distance over time. Okay, now in this case, the distance that the elf will be traveling is equal to the circumference of the Earth. Okay, and the time would be 24 hours. Okay, so, well, we can't use hours in our units. We need to convert that to seconds. So after doing the unit conversions, you should get 24 hours to be, I believe, 86,400 seconds. Yeah, and for your numerator, it is 2 pi times the radius of the Earth, and I've written that down here. The radius of the Earth is 6.37 times 10 to the power of 6 meters. And if you, here, I'll do that calculation real quick. That's 2 pi times 6.37. Okay. Okay. So the tangential velocity is 463.24 meters per second. Okay. So now we know everything we need to solve for tension at the equator. Okay, I'm going to take everything, plug it in, and I'll come back with the answer. So after plugging everything in and solving for tension, you should get 393.64 newtons.